So Harshi, you're not able to see chapter 3A assignment. Let me check to see why that is. Okay, you should be able to see chapter 3 assignment A now. For some reason, it was hidden, but it shouldn't be hidden. Okay. Yeah. Compound interest 3 should not be visible. You're right. Okay, so we're still working on chapter 5. I hope you're enjoying chapter 5. We're going to spend about 3 weeks working on chapter 5. If you have a copy of the agenda, you'll see that we have a test coming up at the end of this week, week 7. So we're about halfway through the course. So maybe there's light at the end of the tunnel, hopefully. And the test will be on chapters 3 and 4 and compound interest 4, 5, and 6. And it'll be 25 questions. And it'll have 15 questions from chapter 3 and 4 and 10 questions from chapters 4, 5, or from compound interest 4, 5, and 6.
Hello, sir.
Hello.
Sir, could you repeat the chapter name, the name of the chapters, please? The
Yes.
number of the chapter.
There'll be 15 questions from chapters 3 and 4, and then 10 questions from compound interest assignments 4, 5, and 6.
And 15 questions, sir, are from the chapters because the net problem, I am unable to listen you, sir.
You're unable to listen?
Yes, of course, sir. Could you repeat the two chapters from which 15 questions are coming?
Chapters 3 and 4.
Okay, thank you, sir.
Okay. So the chapters you need to complete by June 18th would be chapters 3 and 4 and compound interest 4, 5, and 6. Because I will download those marks and they will become part of the second report card. So let's take a look at the questions we want to look at today. We're looking at the concept of markup, and then we'll look at the concept of markdown. Markup is a fairly straightforward concept. When stores buy things, they buy them at a certain price, and then they increase that price and they sell them. So in order to make a living, they have to sell products for more than they buy them for. That's the basic rule that stores have to live by. And the amount that they increase the price is referred to as the markup. And the markup has to cover two concepts. It has to cover the profit they're trying to make, and it has to cover all their expenses. So let's take a look at some of them and see the formulas we're going to be enjoying today. So first one says markup can be based on cost or on selling price. So let's take a look at the basic formulas that we're going to be playing with here. They're going to start with the idea that the selling price, and I'll use S, equals the cost plus the markup. And then they're going to go into greater detail with this concept of markup. They're going to tell us the markup is equal to the expenses and the profit. So they're going to roll this back into here and give us this equation. Selling price equals cost plus expenses plus profit. And so we'll deal with questions where we only have enough information about the markup, and we use this first equation. And we'll deal with situations where they give us information about expenses and profit, and we'll use this equation. With the concept of the markup, they're telling us markup can be based on cost or selling price. So the markup based on cost, for our purposes, is basically translated as the markup divided by cost. And if we have to calculate the markup, that's going to be the selling price minus the cost divided by the cost. And they're kind of hoping that you will recognize this as being our percentage change formula, because that's all that markup is. Percentage change equals new minus old over old. And here we have the selling price, which is the new, the cost, which is the old, divided by the old. So whenever you see markup based on cost, it might help just to remember that it's just percentage change. However, to make things strangely complicated, they tell us that some stores operate where their markup is based on their selling price. So Now we're looking at markup divided by selling price, which is selling price minus cost over selling price. And if we tried to put this in terms of percentage change, it's now a little weird because it's new minus old over new, which is not what we know as percentage change, but that's what they've done in this calculation. So they've given us some information here. What is the regular price of an item purchased for 1,270? So let's make a note of that. If it's purchased for 1,270, they're telling us what the cost is. And if the markup is 20% of the cost, so they're telling us markup equals 20%, so 0.2 times cost. But we know the cost, so we can calculate the markup. It's 0.2, 20% times 1,270. And now we need a calculator. If you're ahead of me, you can put that into the chat box and I'll see how we're doing. I see some answers in there. That looks good. So markup equals 20% times 1,270. And you're right, it's 254. And now they want to know the selling price. So we're going to be using this equation because we don't know anything about expenses and profit. So S equals cost, 1,270 plus 254 equals. So 1,524. So that would be the selling price if it's 20% markup based on cost. But then they've asked us a very similar question. What would the selling price be if it's 20% based on the regular selling price? So we have the same situation. They've told us the cost is 1,270. The markup equals 20%, 0.2 times, in this case, selling price. And now this is a little weird because we don't know the selling price. Over here, we could calculate the markup because we knew the selling price. Here, we don't know the selling price, but amazingly enough, the wonders of algebra will allow us to solve this. We can still put it into this equation, S equals C plus M, and we don't know the selling price. We do know the cost, and we know something about the markup. It's 0.2 of S. And now we can see that we've got one equation with one unknown. This 0.2 has to leap over here. S minus 0.2 S equals 1,270. So there's an invisible one here. So 1 minus 0.2 is going to become 0.8 S equals 1,270. And now this is going to be S equals 1,270 divided by 0.8. And now a calculator will allow us to figure that out. So this is becoming, and I can see the answer in the chat box, 1,524 8750. So making the markup part of the regular selling price looked a little weird when we first looked at it, but amazingly enough, with algebra, it allows us to figure out what that would be. I can't imagine why a company would do it that way and not do it this way, which is so much simpler. But the textbook tells us that some companies do it this way, some do it this way, and I have no choice but to believe them. So, any questions on what happened there? I would advise you, when you're going through these questions, to keep referring to the formula sheet for chapter 5. These formulas are on there, but they're fairly useless to you until you get a feel for how to work with them. So let's take a look at the next one. So it tells us the regular selling price of merchandise sold in the store includes a markup. Notice I've put in brackets here margin. And the reason I've done that is because markup and margin mean the same thing, but most of the time they'll use the word markup. Once in a while, they'll use the word margin to see if they can confuse you. But just remember that markup and margin are the same thing. So it's a markup of 40% based on the regular selling price. So what we know is markup equals 40%, so 0.4 S. During a sale, an item that costs the store 180, so we know the cost equals 180, was marked down 20%. So what was the regular selling price? So as we don't have information about expenses and profit, we're going to go S equals C plus M. And we're going to plug in what we know, just like we did in the last question. S equals 180 plus 0.4 S. So now this 0.4 has to leap over. S minus 0.4 S equals 180. I just got a message saying you could see the whiteboard. Were you unable to see it earlier? So we have over here 0.6 S equals 180. So S must equal 180 divided by 0.6. So now with the help of a calculator, we can figure that out. And quite correct, this equals 300. So that would be our answer to part A, 300. What was the regular markup? Now that we know S. We can go back to M equals 0.4 S, but we know S equals 300. So M equals 0.4 times 300. And people are there ahead of me. That's good. 0.4 times 300 indeed equals 120. Okay. So this would be 120. And the sale price what have they told us? It was marked down 20%. So now they're expecting us to remember this formula, N equals L 1 minus D, because a markdown and a discount are exactly the same thing. So this is now going to become our sale price. N equals 300 was the list, and 1 minus 20%, so 0.2. So this becomes 0.8. So we can figure out 300 times 0.8. So when it was marked down 20%, it's selling for $240. So that would be this answer. So any questions on how that worked?
Hello, sir.
Hello.
Sir, I did not understand the last part, N is equal to L1 minus D. How it's work?
Okay. This is the equation we used in the first part of chapter 5. So N is the net price and L is the list price. But in order to use it in this scenario, we treat the higher price, the regular selling price, as the list price. So we make the L equal to 300 and the sale price is the net price, because in the first part of chapter 5, they talked about putting things on at a discount. And here they're talking about markdown, right? We had the concept of discount. And now they've changed the terminology and they're talking about markdown. But these two are the same thing. If we could have been told here there was a 20% discount, but we were told there's a 20% markdown, but they're the same thing. So we're just going to use exactly the same equation, but we have to put these numbers in there, and we solve it the same way we did in chapter 5, part A. Does that help?
Yes, sir. Thank you, sir.
And we'll do this a lot because they'll give us a lot to do with markdown, and markdown and discount are the same thing. They've just changed the terminology. So let's take a look at number 3 here. So what have they told us? An item that cost the dealer $350 less 35% and 12.5%. So again, they want us to use the formulas we had in the beginning of the chapter. So they've told us it cost the dealer $350. So cost equals $350, but there were 2 discounts. 1 minus 0.35 and 1 minus 0.125. So their real cost is not 350. The real cost is once we've solved this, and this is what they want us to do for part A. So 1 minus 35% should be 65%, so 0.65, and 1 minus 0.125 should be something like 0.875, but I'll check that to make sure I'm not screwing it up. 1 minus 5%. Oh, good. 8.75 is good. So we can multiply this out to find out what their cost is now. 350 times 0.65 times 0.875. And I too am getting 199.06. It's got to be 2 decimals because it's money. So that would be their cost. And it carries a regular selling price on the tag at a markup margin of 150% of cost. So now they're telling us markup equals 150%. So 1.5 times cost. But as we know what the cost is, we can figure out what this markup is. Markup equals 1.5 times 199.06. Let's see what that is. $298.59 looks to be a good answer. So now that we know their cost and their markup, we can figure out their regular selling price. We're going to do S equals C plus M because we still don't know anything about expenses and profit. So S equals 199.06 plus 298.59. So I see a bunch of answers in there and I'll try to catch up. Plus 199.06. 497.65 looks to be good. That's the weirdest looking 7 I've ever done. Let's see if I can fix it. So in terms of A, B, C, and D up here, our markup margin turned out to be 298.59, and the selling price was 497.65. And then they've said for quick sale, the item was reduced 30%. So again, this is just a discount. So we're going to use N equals L 1 minus D. And we don't know N, but we know the list price was 497.65. And we know this is a 30% discount. So 1 minus 0.3. So this will become 0.7. And we should be able to calculate that times 0.7. And I too am getting 348 point, I don't know whether it's 35 or 36, because the last digit's a 5. Let me store that and see which way it goes. I'm going to get this up to 36. So that would be our answer here. 348, 36. So any questions about how those calculations worked? Basically, they're just getting you to get familiar with all these formulas and relationships. Let's take a look at number 4 here. So an article sold, or no, cost $900. So there's no discount, or there's no trade discounts. So we're fairly clear that their cost is 900, and their selling price equal 2520. So the dollar value of the markup so I shouldn't call it D, M equals 2520 minus 900 is 1620. And then they want to know what is the markup as a percent of cost. So markup based on cost is equal to markup divided by cost, which we could write as selling price minus cost, but we've already got the markup here. They've already made us calculate it, over 900, and we'll go times 100 to turn it into a percentage. So you're right, 180. Sounds like we're playing darts. So it's 180%, not me playing darts, you understand, but someone who can play darts well. Markup based on selling price for our purposes is markup divided by selling price, 1620 over 2520 times 100. So 162, that didn't work. 1620 divided by 2520 times 100. And we don't really know how many decimal places, so let's go to 2. 64.29%. And that's all there is to it. When they say markup based on cost or as a percent of cost, they just mean divided by cost or divided by selling price. I'm confused between selling price and regular selling price. They're there's no difference, except sometimes, let's see if we can explain this. We're gonna deal with things that are put on sale. And so we'll have to differentiate between the regular selling price and the sale price. But when they just talk about selling price, they are just talking about the regular selling price. So it's just the terminology. I don't know why sometimes it's referred to as selling price and sometimes they specify the regular selling price. But that's all there is to it. They're basically the same thing. If I run into situations where they're not, I'll point out why they have to sort of change it. So determine the cost of an item that sold for 1904. So we see the selling price. And there was a markup. So markup was 40%, so 0.4 of cost. So what they want us to come up with is to solve for cost, but we should be able to put this into our basic equation. S equals C plus M. And we know this 1904. We don't know the cost, but we can replace markup with 0.4 cost, at which point we've got one equation and one unknown. There's an invisible one here. So this becomes 1904 equals 1.4 cost. And now we can divide through and solve for the cost. 1904 divided by 1.4. And that should give us an answer. I see we have an answer. 1904 divided by 1.4. And we get 1360. So that's all they wanted you to do there. Plug those into that basic equation and come up with an answer. So let's see what else they can do to us here. So a markup of $90 is made on a sale. So what they've told us is that the markup equals $90. If the markup is 45% of the selling price, so they've also told us markup equals 45%, 0.45 of the selling price. What was the, for some reason I've lost the end of this sentence. Let me go get it. How did that happen? What was the cost? That's all there was to it. So what they're expecting us to do here, there's no cost in here, but if we put these two things together, because if markup equals 90 and markup equals this, what they're expecting us to do is come up with an equation that says 90 equals 0.45 s, at which time we can solve for s. S equals 90 divided by 0.45. And I don't have a clue what that is, but I see some answers, so let's hope some of them are good. 90 divided by 0.45 is 200. So now that we know the markup and the selling price, we can go back to this equation. S equals C plus M, and S is 200 cost plus 90. So cost must equal 200 minus 90, which I'm going to take a big chance here and say it's 110. So that's what they wanted you to do there. Not quite sure why they wanted you to do that, but that's what they wanted. Let's see what other nonsense they can inflict on us here. So a surf shop reduces the price of a paddleboard for quick sale from 1560 to 1195. So what do we know? We know the selling price, regular selling price of 1560, and we know the sale price of 1195. So this is basically our net price of 1195. Let's actually replace this S here with the list price. It'll work easier if we distinguish the list price, the net price, and then the dollar value of the markdown is the big D. So 1560 minus 1195 is 365. And the reason I've put this in terms of list, net, and discount is that we learned how to use this process in the previous part of the chapter. And the rate of markdown, the little d, is equal to the dollar value of the discount over the list. So 365 over 1560, and then we'll have to go times 100 to turn it into a decimal. So let's see what that becomes. And I'll have to store that. So I'm getting 23.3974359%. And they've told us compute the rate of markdown correct to 1/100th of 1%. So 1/100 times 1%. What does that give us? 1% divided by 100. And that gives us 0.0001. So this was just a really weird way of saying correct to 4 decimals. Seems strange that they do it that way, but that's what they're asking for, 4 decimals. So 23.3974%. So whenever you're being asked to find the rate of markdown, put it into this framework here. And have the higher price, the lower price, the difference, and then the difference divided by the higher price. That's the most basic, straightforward way to calculate either the rate of discount or the rate of markdown, right? They're the same thing. Rate of markdown equals rate of discount. For some reason, when you read the textbook, they present rate of markdown as if it's some sort of a different concept from the rate of discount that we've already covered. But just remember, they're exactly the same thing. They've just changed the terminology. So what have they done to us here? A retailer buys an appliance for 1,480 less 25% and 15%. So we can work with that to do part A, because they've given us the cost, but we have to do a little bit of work to get there. So A, N equals 1,480, 1 minus 0.25, and 1 minus 0.15. So figure out what these really are, 0.75 and 0.85, and multiply that out to get their cost. 1,480 times 0.75 and times 0.85. So I'm getting 943.50. So that would be part A. And then the store prices the merchandise at a regular selling price, which is just their selling price, to cover expenses of 40% of the regular selling price and a net profit of 10% of the regular selling price. So here they're using the word regular, but they're just talking about selling price. So in this case, now we've suddenly come to a situation where we're going to distinguish between expenses. So their expenses are 40%, 0.4 of S. And the profit, so P, equals 10%, so 0.1 of S. And notice I've put the word overhead in here because most of the time they refer to expenses as expenses, but sometimes they refer to expenses as overhead, but they're the same thing. So if you just see the word overhead, not overhead expenses, remember that's just expenses. So what they want us to do is figure out the regular selling price. So we're going to go back to this equation, S equals C plus M. But now we've been told that markup, or now we have to use the fact that markup is equal to expenses plus profit. So we have to roll this back into this equation, S equals C plus E plus P. And now we can solve it because we know the cost. That's our net price up here, $943.50. The expenses are 0.4 S, and the profit is 0.1 S. And this is S here. So these two have to leap over, and it becomes, at this point, very difficult to tell the difference between my S's and my 5s. Let's hope we can keep them straight. S minus 0.4 S minus 0.1 S equals 943.50. And so there's an invisible 1 here. So this is 1 minus 0.4 minus 0.1. So this is 0.5 S, still equal to 943.50. And so S equals 943.50 divided by 0.5, at which time I need a calculator. Although I could have just looked in the chat box. So that's our answer to part B, the regular selling price. And then we have to continue reading the sentence because they say, during a clearance sale, the appliance was sold at a markdown of 45%. So now we're using this equation, N equals L 1 minus D. We're looking for the net price, which is going to be the clearance sale price. We know the list price is 1887, and we know the markdown or discount is 45%, 0.45. So this is really 0.55. So 1887 times 0.55. So the clearance sale price should be 1037.85. So let's look at what we've done up here. They first off asked us the cost, and we got 943.50. Then they asked us the regular selling price, and we got 1887. Then they asked us the clearance sale price, and we got 1037.85. So we're only halfway through here. What are the regular expenses? Okay, let's go back to here where we had this equation. E equals 0.4 times the regular selling price of 1887 So we can calculate the regular expenses now. So 1887 times 0.4 should be 754.80. And then what did they ask us? So that's 754.80. And then it says, when a store puts an item on sale, do the regular expenses change? And this is just a theoretical concept, but the answer is no. Because the regular expenses are based on things like the heat, rent, light, taxes, wages, all the costs you can imagine of running a business. But if you put one item on sale, none of those expenses changes. So whenever you're calculating the expenses, just because they've put something on sale, the regular expenses do not change, which is why we put 1887 in here, not 1037, right? The regular expenses do not change. So what was the operating profit or loss when the appliance was sold at the clearance sale price? So what they want us to do, I'll see if I can create a little space here for this. What they want us to do is go back to this equation, S equals C plus E plus P. But instead of using the regular selling price, they want us to use the sale price here. And we know all of these things except the profit. When they put this on sale, it's their profit that's going to take the hit. So their sale price was 1037.85. Their cost was $943.50. Their expenses didn't change. That's why they wanted us to make sure we knew they didn't change. 54.80 plus profit. And now we can solve for profit equals 1037.85 minus 943.50 minus 754.80. And now I need a calculator. So 1037.85 minus 943.5 and minus 754.80. So this is telling us they made a loss of $660.45. So let's hope that works out. Negative 660.45. So any questions on how that worked for us?
Excuse me, sir.
Yes.
Sir, could you explain from here where selling price is equal to cost plus markup and markup is equal to expense plus profit?
Well, we know that the markup is the total amount that they mark this up. But in this case, they've divided it into expenses plus profit. So we knew their markup was $754.80. Let's, we could have figured out their profit is equal to 0.1 times 1887. Let's see what that is. Is 188.70. And so the total markup that they wanted to make on this item would have been plus 754.80. They wanted to make a markup of $943.50. Does that make sense? That's the markup they wanted. But when they put this thing on sale at 45% off, they're now, in fact, making a loss from what they wanted to make of $660.
Thank you, sir.
Okay, so sometimes they'll give us, like they gave us several equations where they didn't differentiate between expenses and profit. But in this case, they've told us the details of percent for expenses and percent for profit. So that's why we had to do S equals C plus E plus P, because they gave us information here that allows us to replace the markup. So it just depends on the information they give you, whether you can just work with C plus M, or whether you have to work with C plus E plus P.
Thank you, sir.
Okay,
I got it.
let's take a look at the next question they've given us. So they're going to introduce some other concepts here in this question. Let's first off take a look at these concepts. They're introducing to us here the concept of the break-even price. So let's talk about that for a minute. The break-even price is the price where we cover cost and expenses, but make no profit. So the break-even price would be equal to cost plus expenses, and that's it. That would be the break-even price. So whenever they talk about the break-even price, they're just telling you that we're selling at a price that costs equal, or selling price equals cost plus expenses, and profit equals 0. They're also going to talk about absolute loss. So if a company is making an absolute loss, then they're selling at a price that is lower than their cost. So the way they refer to this is they will say, they'll ask you, what is the price, or what is the lowest price they'll say, what is the lowest price at which the item can be sold without making an absolute loss? And in this case, the selling price is just equal to cost. In other words, we're not making any profit and we're not covering our expenses. The lowest price we can sell without making an absolute loss is the selling price is equal to cost. So let's go back and look at this question where they're using these concepts. Let's see. Par Putters Company sells golf balls for $29 per dozen. So they're fairly clear about their selling price. S equals 29. The store's overhead expenses are 43% of cost. So their expenses are 43%, 0.43 of cost. And the owners require a profit of 20%. So they're telling us about profit is 20%, 0.2 of cost. So armed with this information, we can determine how much they bought the golf balls for, because we can go back to this equation, S equals C plus E plus P. We know 29 equals cost plus 0.43 cost plus 0.2 cost. And there's an invisible one here, so we can add these together. 1 plus 0.43 plus 0.2. So this becomes 29 equals 1.63 cost, which allows us to solve for cost. Cost equals 29 over 1.63. What did that become? $17.79. 17.79. So we now know their cost. What is the total cost? The price needed to cover all expenses. So total cost equals expenses. Oh no, back up a bit. Total cost equals cost plus expenses. So what do we know about their expenses? We know they're over back here. Expenses equals 0.43 cost. So equals 0.43 times 17.79. So what will that be? 17.79 times 0.43 is 7.65, I guess. So we can put that back into this equation. Total cost equals 17.79 plus 7.65. Total cost equals 25.44. No. Paul Winders asked, total cost will not cover profit, and that's correct. Total cost does not cover profit. Total cost is just cost plus expenses. Those are your actual costs. Your expenses, or not your expenses, your profit is above and beyond your total cost. So we've got the total cost. What is the total cost needed? We've decided that's 25.44. What is the price needed for the store to break even? Well, the break even is exactly this, right? We don't really need to calculate it. They've already made us calculate it. It's 25.44 because there's at break even, there's no profit. So at break even, selling price equals total cost. So that's the price the store would need to charge to break even. What is the highest rate of markdown at which they will break even? So when we're calculating markdown, remember, always set it up like this. Have the list price, the net price, the dollar value of the difference, and then you can calculate the rate of discount. So the list price is always the highest price. In this case, it's 29. The net price is the lower of the two prices. We decided it was 25.44. We'll need to calculate the dollar value of the discount. Turns out to be $3.56. And so the discount is equal to the dollar value of the discount divided by the higher price. So 356 divided by 29 times 100. So 3.56 divided by 29 times 100. And they didn't tell us how many decimals to go to, so let's go to 2 decimals. 12.28. So,
Sir, from where
yes,
we got this value 3.56?
oh, we did the list
Okay, got it,
minus the
got it.
net to get
Okay, thank
the
you, sir.
difference.
Thank you, sir.
What does absolute loss mean? Here we would have to explain it, and we've explained it over here. If a company makes an absolute loss, they are selling the item at a price lower than cost. And then they said, what is the lowest price the store can charge without making an absolute loss? And so let's go back over here. The lowest price they can sell is cost. And so we know the cost. So over here, we figured out the cost. So the lowest price they can charge without making an absolute loss, we've already figured it out to be 17.79. And then they want you to do the same calculation again. They say, what is the highest rate of discount? Notice they've slightly changed the wording. They said rate of markdown. Now they say rate of discount, but they're exactly the same thing that can be advertised without incurring an absolute loss. So go back to the higher of the prices. The list price is the 29. The net price is the lower price. Now it's 17.79. The difference between the two of them is 29 minus 17.79. So now I've got 11.21, and the rate of discount or the rate of markdown is the difference divided by the higher price. So 11.21 divided by 29 and times 100. And they didn't ask us how many decimals, so we'll go to 2. And I too am getting 38.66%. So they're going to ask you lots of questions where they want you to figure out the rate of markdown or the rate of discount. Always remember to set up these 4 concepts and solve it that way. I find it's easier to keep straight in your head what's going on. The higher price, the lower price, the difference, and then the difference divided by the higher price. This again is just a direct sort of application of our percentage change formula that they made us learn in chapter 3.
Sir,
Yes,
I have a question.
sure.
Why the answer to F is 1779?
That's the lowest price the store can charge without making an absolute loss. If they charge anything below cost, then that's what they refer to as making an absolute loss. So back here, we calculated the cost as being 17.79. So we didn't have to recalculate it. We already knew what the cost was. So if they charge a price below 17.79, 0.79, they'll make an absolute loss.
Okay.
Okay,
Thank
because
you.
we'd already calculated that once, I didn't bother calculating it again. We just know what the cost is.
Okay, thank you.
So what else have they done to us? Something to do with the Mountain Equipment Co-op. So the Mountain Equipment Co-op purchased tents for $334.89 less these three ridiculous discounts. Okay. The store's overhead expenses are 55% of cost and normal profit is 21% of cost. So first off, we have to figure out how to deal with these stupid discounts. Because they've done this to ruin your day for sure. Oops, let's get. So 1 minus, and they want you to be looking at that table, which gives you what they call commonly known fractional equivalence. 33 1/3%. When we turn it into a fraction, what is that? And I'll wait till somebody puts that into the chat box for us. 33 1/3% just translates to 1/3. How about 16 2/3%? What is that really equal to? One over 6, that's correct. How about 8 1/3%? What is that really equal to? One over 12. And so this equation becomes much easier if we use these commonly known, supposedly commonly known, fractional equivalents. So this becomes 1 minus 1/3, 1 minus 1 over 6, and 1 minus 1 over 12. Again, I'm going to solve what's in these brackets first. 1 minus 1/3 leaves me with 2/3. 1 minus 1/6 leaves me with 5/6. And 1 minus 1/12 leaves me with 11/12. And now I definitely need a calculator. So I'm going to go 2 divided by 3 equals times 5 divided by 6 equals times 11 divided by 12 equals, and then times 334.89. And what are we going to get? I'm getting 170.55. And if anybody's not getting that, now should be a good time to worry and figure out what you're not doing properly. So what is the regular selling price? They've told us the store's overhead expenses equals 55%, so 0.55 of cost, and profit equals 21%, so 0.21 of cost. So as they've told us about expenses and profit, we can roll everything into this equation. Because we know most of this stuff. Although we said it was the net price, this is their cost. 170.55 plus 0.55 times cost plus 0.21 times cost. But we can figure these ones out. Let's put them up here. 0.55 times 170.55. What is that equal to? Uh, 93.80. And here we've got 0.21 times 170.55. And I'm getting 35.82. So now we can put those all back into this equation and actually solve it. Plus 93.80 plus 35.82. So yes, I see some answers there. That's good. 170.55 plus 93.80 plus 35.82, and looks good. $300.17. So 300.17. So at what price can the tents be put on sale so that the store incurs an absolute loss or an operating loss of no more than 20% of the overhead? So first off, let's find out what 20% of the overhead is. $0.2 times the overhead is 93.80. So what would that be? 0.2 times 93.8. 18.76. So we need to figure out what their break-even price would be, because if they're making a loss, then that's below break-even. So break-even equals cost plus expenses, and we know their cost was 170.55, and their expenses were 93.80. So what would the break-even price be? So the break-even price would be 264.35. Now, if they're making a loss of 1876, then we can find the sale price. So sale price equals 264.35 minus this 18.76. Let's see what that equals. $245.59. So that would be the price the tents can be put on sale. So they incur an operating loss of no more than 20% of the overhead. We found 20% of the overhead. We found the break-even price, and they're making a loss, so it's below break-even of no more than this 1876. So what is the maximum rate of markdown at which the tents can be offered for sale? So here we're back to setting up the list, the net, the difference, and then the rate of, which is the difference over the list. So the regular price they wanted, which is the higher price, is 300.17. But the lower price in this case is this price they're offering of 245.59. So what's the difference between those two? I'm getting 54.58. So this becomes 54.58 over 300. Let's see what that became. And you're quite correct. It looks like it becomes 18.18%, because they didn't tell us how many decimals to go to. So that was that was a little tricky because of this thing here, an operating loss of no more than 20% of the overhead. So we had to first off get 20% of the overhead, then find the break even, and then find out what that price was. So any questions on how that worked? That part C makes it into quite a tricky question.
Excuse me, sir.
Yes,
So what is the answer of part C? It's 18.76.
yes, I could put that up there. This turned out to be 18.18%. And this, what's the, what price? This one turned out to be 245.59. So now we get to do something totally different. Let's take a look at compound interest assignment 7. I'll go over and look at the Excel files I've sent you. That will be way easier than me trying to do these on the fly. We saw how badly that went the first time I tried to do it. Let's find these. So you should be looking at an Excel screen at the moment. Is that correct?
Yes, sir.
Okay, and I'll try and enlarge this so you can actually see it. So what we're dealing with in this section are called deferred annuities. And what they mean by deferred annuities is we're going to have one period of time where there's just money earning interest, and another period of time where there's payments, either payments going to somebody or payments being used to pay off a loan. So there's two basic situations here. One situation is somebody puts a chunk of money into an investment. They wait a certain period of time. That's called the deferment. And then payments come out. That's the annuity period. That's sort of one situation. The other situation is somebody borrows a bunch of money and they don't have to make payments for a certain amount of time. That's the deferment period. And then they have to pay it off. That's the annuity period. But graphically, these both basically look the same. So let's read this. An annuity with a cash value of 14,500 earns 7% compounded semi-annually. End of period semi-annual payments to the beneficiary are deferred for 7 years, then continue for 10 years. How much is the amount of each payment? So as it's end of period, that tells us it's an ordinary annuity, not annuity due. Compounding semi-annually and semi-annual payments tells us this is a simple annuity, not a general annuity. But the deferred for 7 years tells us this is a deferred annuity. So we will always need to do two separate calculations for deferred annuities. And it's not like this is all that new, because in some of the questions you've already done, they've already done questions like this just to be annoying. So I like to sort of draw a diagram to help me get clear in my mind what's going on here. At this point here is the 14,500. It's going to earn interest for 7 years at 7%. And so we have to know how much money ended up at the top here. And then for another 10 years, they take out payments. And so first off, we've got to move this money forward. We could use Excel's future value formula to move the money forward. So we're doing the future value. And what we find out is that after 7 years of interest, they would have 23,000 and something. So that's what we would start the next calculation with. The next calculation we'd have to do is we're looking for the payment. So now we can solve for the payment if we used Excel's payment formula, and we would end up finding out payments, excuse me, of 1,651.45. Now notice we have to do a bit of calculating here. We have to calculate the number of periods as 14, and we have to calculate the rate. We can't just put in the 7%. We've got to go 7% divided by 2. This is basically I. So that's how we would do this if we were using the Excel formulas. And it's probably easier or more convenient to do it on the BA2 Plus. Make sure the BGN is not up, right? So if it is up, you can get rid of it. And we've got to tell it the payments per year are 2, even though payments are semi-annual, even though for the first part, there's no payments. We still have to tell it the payments and the compounding is semi-annual. But the calculator will automatically set CY to 2, which is the compounding. So we have to again calculate the 14 semi-annuals. Although for the BA2 Plus, we don't have to calculate I. We can just put in 7, not 7%, not 7% divided by 2, just 7. The 14,500, the cash flow concept says that has to be negative because the money is going into the investment. For the first 7 years, there's no payments. And we don't know the future value, so we ignore it. And we compute the future value, and we get the same answer we would have got with Excel. And now we can use the BA2 Plus to calculate the payment. The payments per year and the compounding per year is still 2. We have to calculate 10 times 2 is 20. The interest rate is still 7. The present value, we've got to take from the previous calculation, but it's still money going into the investment, so we have to make it negative. We can ignore the payment, but at the end of the time period, there should be no money left. So the future value is 0. I've said we compute future value here, which is stupid of me. I'll have to change that to payment. One of these days, I'll actually learn to proofread my own shit, but sorry about that. You might want to change that on your sheet because we're computing the payment, not the future value. And we get the same answer we got previously. The bad news is we could also do this by hand. The formula for the future value is basically from formula 9.1, because this is not an annuity. This is just a sum of money for a certain amount of time. In this case, we have to calculate I, and we have to calculate N. And if we do it correctly, we'll come up with exactly the same answer that Excel and the BA2 Plus came up with. Now we're doing an annuity, so we have to find this annuity formula. It's in chapter 11, and it looks like this. We know the present value, we know the value of I, we know the value of N, and if we plug this into this formula correctly, you'll find you get, and I don't know why I've said future value here. That's ridiculous. Let me see if I can fix that. So that's unfortunate, but it's the payment that is 1,651. So any questions on how that worked? We're not learning any new formulas in this section. The only thing they've done to make our life more difficult is they've included this annuity in every situation. So any questions on that one before we look at the next one? So let's take a look at this one. Yes. I heard a question.
I said it's okay, sir. It's fine.
I didn't quite understand the question.
I was saying it's
Oh.
okay.
It's okay? Okay. Now I've got a message from Harpreet saying you're not able to get the same value for the payment. Are you doing this by hand, on Excel, or in the BA2 Plus, Harpreet?
With the BA2 plus.
With the BA2 Plus? Okay,
Yes.
let's go over to the BA2 Plus and do that. Let me
Yes,
find
yes.
the numbers again that we plugged in. There they are. Let me stop sharing it. I think she has BGN up. Harpreet, do you have BGN up?
Yes, sir.
Oh, yeah, in this case, you can't have BGN up because it's not a annuity due.
Okay, sir.
Try it
Sir,
without the
could you do
BGN.
it on,
What's that?
could you do it on a calculator?
Yes, I'm just gonna find my calculator. Okay, so you can see the calculator,
Yes, sir.
okay? So, the first calculation we did, oh, I don't want that. I want this one. Now, where'd my calculator go? Okay, so we can see the calculator. And notice I've got BGN up. So the last calculation I did must have been an annuity due. So I got to get rid of that. Go second, begin, second, set. And now the BGN is gone. So now I'm good to go. So because this is semi-annual, I've got to have second PY equals 2, enter and clear. I don't have to set CY because it's a simple annuity, so I don't have to set CY and PY separately. The calculator automatically assumes it's a simple annuity, unless we force it to realize it's a general annuity. So it was 7 years, but 2 times a year. So we have to do that calculation, and that goes into N. The interest rate was 7%, so 7 into IY. The amount of money that was in the present value had to be invested was 14500. But because it's money going into the investment, it has to be negative, and put that into present value. And then during this period, there's no payments, but we have to tell the calculator that. And we can ignore future value because that's what we're calculating. So go compute future value. And we can see we're getting this number here, which we're going to round to 23,471.07. So we can ignore that. And now we can go down to the other calculation. So I'll clear that. You can all see the calculator now. Again, we don't want
sir.
BGN. Yes. So we don't want BGN up. We want second PY2, enter and clear. We could have ignored that because we knew it was set already. We want 10 years, 2 times a year, which is 20. So 20 into N. We want the interest rate to be 7. We could ignore it, but I'm going to put it in there anyway, even though it was already there. But in the present value, that's where we're putting the sum of money that was accumulated over the past 7 years. So 23,471.07. But in terms of this time period, this is money that has to go in. So we got to make it negative into present value. We can ignore the payment because that's what we're going to solve for. But at the end of the time period, there has to be no money left. So we put 0 into future value, and we're going to compute payment. And we're getting 1651.449, which we're going to round off to 0.45. Does that help? Are you able to get the same result on your calculator?
Yes, sir. I got it.
Okay, that's good. So let's get rid of that. Let's go to the next question. Let's enlarge this. Oops, not shrink it. So what do we know? The Omega Venture Group needs to borrow to finance a project. Repayment of the loan involves payments of $8,500 at the end of every 3 months for 8 years. No payments are to be made during the development period of 3 years, and interest is 9% compounded quarterly. And they're asking us 3 things. How much should the group borrow? What amount will be repaid? And how much of that amount will be interest? So payments are made at the end of every 3 months. So this is an ordinary annuity, not an annuity due, because it's at the end of the time period. Payments are every 3 months, and compounding is quarterly. So this is a simple annuity, not a general annuity. And no payments are being made for the first 3 years. So this is a deferred annuity. So we know we're doing two separate calculations. The diagram here looks very similar to the diagram we had previously. The only difference is the logic of our calculation will be working differently because they've given us enough information to solve the second time period and figure out how much money had to be here. And then we have to work backwards to figure out what the present value was. So this is sort of opposite from what we were doing last time, although the shape of the diagram is exactly the same. So they borrow a chunk of money. Interest is owing on the money for 3 years. That's the deferment. Then they pay the loan off with quarterly payments for 8 years. So let's take a look using Excel's present value formula. We know the rate, but for Excel, we have to calculate it. 9% divided by 4. This is basically our calculation for I. We also have to calculate the number of periods. It's 8 years, 4 times a year is 32. During this time, there's a payment. We're making this payment negative because we have to pay this. We're making payments, not money that's coming to us. The future value is 0. We don't owe any money once the loan is repaid. And we know it's an ordinary annuity, so this has to be 0. So what we find is that the amount of money they were owing before they started to pay it off was 192,000. So now we're going to work up to the 192,000. We're still calculating present value. I've screwed this up. I've said 7 here and 9 up here, and the interest rate was 9. So please excuse me while I fix that. That's the danger. Oh, didn't it change? 9. The dangers of cutting and pasting still won't change. I wonder why. Okay. For this time period, it's 3 years, but quarterly, so 12 periods. During this time, there are no payments, and the future value is the amount of money we need to pay off. So I've made this negative. Not really sure if it should be negative. Oh yeah, this should be negative because the amount of money we borrowed was 147, but that's money that we got. That money came to us. So that money has to be positive according to the cash flow concept. And it's still an ordinary annuity, so type is 0. So we can see that the group must have borrowed this 147,000 something. So I played with it a little here to see how sensitive this was to rounding. I used the unrounded value for the present value and the rounded value, and it made no difference to the final answer. So good to check whether it does or not. We could also do this on the BA2 Plus, of course. We have to make sure BGN is not up. And we're making the compounding and the payments quarterly. So PY equals 4. For the second time period, it's 8 years, 4 times a year, 32. The interest is 9%. We're not worried about PV. We are worried about the payment. It's 8,500. We're paying it, so it has to be negative. And once we've paid the loan off, there should be zero money owing. So then we're computing, and this should read PV. And we should get the same answer we got using Excel. And so this is the amount of money they have to have, or that they will owe before they start paying it off after the 3 years deferment. So we can calculate present value again. The payments per year are still 4, and the calculator would automatically set the compounding to 4. This was for 3 years, 4 times a year, so 12. The interest is still 9. We can ignore present value. During this time period, we made no payments. This was the deferment. And the future value is the number we generated from the previous calculation. And we've rounded it to 2 decimals. We compute the present value and we get the same 147,000 that we borrowed. If you try that on your own, is it working? Okay, let's take a look at the formulas if we were inspired to do this by hand. The first calculation we're going to do is an annuity because we're making payments. So this is formula 11.2, calculating the present value. And if we plug all this information in, we should indeed get the 192. If you're not getting the 192, let me know and we can go through it. And the second calculation is not an annuity. It's just finding the present value of a sum of money at a certain rate of interest for a certain amount of time, but it's not an annuity because there's no payments involved. But if you plug in the correct information into this formula, this is what you should get. So we've done all that work and we've only answered part A. We know the amount the group borrowed. To find the amount they've repaid, we need to multiply the payment by the number of payments. So we could have done this before. So 8,500 times 32 gave us 272,000. That's the total amount they ended up paying on this loan. And so now that we know the total amount they repaid and the total amount they borrowed, we can take the total amount they borrowed from the total amount they repaid and find out how much interest they paid. So over the 3-year deferment and the 8-year payment period, they ended up paying $124,000 in interest. So any questions that you feel you would like to ask at that point?
So could you do it on a calculator?
Do the hand calculation on the calculator?
Yes, sir.
Yes, okay. Let's stop sharing this. Let's see. Get rid of this calculator for a minute. And what am I trying to look for? A whiteboard. Where did the whiteboard go? Okay, so let's start with this calculation here. The present value equals the payment 1 minus 1 plus I to the power of negative n all over I. So the first thing you need to do is calculate I. And it was 9% divided by 4 because it's quarterly. So 9% divided by 4, I'm getting 0.0225, and I'm going to store that in register 1. The next thing you need to know is n, and this was 8 years, but 4 times a year equals 32. So I'm not likely to screw that up. So I'm not going to bother storing it. So when I come back over here, we know the payment was 8,500. So let's figure out how I'm going to plug this into my calculator, and then we'll go to the calculator and do it. So we're going to do 1 plus recall 1, see what that equals, then y to the x, recall, I better put this in brackets, y to the x bracket. Oh no, I didn't store x. That's okay. Or I didn't store n. So that's okay. We'll just do y to the x 32 plus or minus equals. And then we've got to take this away from 1. So I'll hit plus or minus, and plus 1 equals. So then I've got everything above the line, and we'll go divided by recall 1 equals, and then we'll go times the 8,500 equals, and this should be our answer. So now let's find the calculator. Where did it go? So can you see the calculator?
Yes, sir.
Okay, so we'll clear what we were doing there. So the first thing we had to do, of course, was find I. So 9% divided by 4 equals, and I'm going to store that, store 1. So I know I've got I stored there. Then we had to find n. It was 8 times 4 equals, and we could just make a note of 32 because we're not likely to round it off, but we'll need it in a minute. And then we're going to go back to the calculation. We're going to start with 1 plus recall 1 equals. So we've got what's in that little bracket. Then y to the x, 32, but it's a negative 32 equals. And then we want to take this away from 1. So the easiest thing to do is to make this negative and go +1. Seems a little weird, but adding a negative is the same thing as taking away. And then we want to divide all of this by I. So divided by, recall 1 equals. So now we should have everything inside the bracket. We can go times 8,500. And we're getting 192,420,2306, which is exactly the answer we hope to get. So did that calculation work for you?
Yes, sir.
Okay, let's look at the second part of the calculation. The second part of the calculation is just a compound interest calculation, but not an annuity calculation. So let's clear that. We still need I, but we've got a new time period. So this is 3 years times 4, because it's quarterly, is 12. And that's a simple enough number that I don't need to store it. So let's take a look at what we're going to have to do. We're going to start below the line in the little bracket. 1 plus recall 1. So that's what's in the bracket. And then to the power of, so y to the x, oh, not 32. Said I wasn't going to screw that up, and I did. 12 equals. And then this is below the line. So I need to hit 1 over x, which is my invert key, to put it above the line. And then I can go times the future value, which was this number that we just calculated, 192,420.23. And we're getting the $147,329.91. Did that work for you?
Yes, sir.
Okay. So let's get rid of the calculator for a moment and go back to sharing the Excel file. So, does anyone have any questions about question 2 before we look at question 3? Okay, let's try question 3. See if I can enlarge it here. So, someone by the name of Ariane borrowed $6,200 to buy a vehicle to drive to school. She plans to study
So
for.
we are just seeing the monitor, not the Excel file.
Oh, you're not looking at the Excel screen?
Yeah.
Oh, I wonder why not. Let's try that again. Thank you for letting me know. How about now?
Yes, we can, sir. Thank you.
Okay. Yeah, I don't know how I screwed that up, but I'm glad we fixed it. So Ariane borrowed $6,200 to buy a vehicle to drive to school. She plans to study for 3 years and then start her career using her education. Interest is charged on the loan at 6.74% compounded annually. If she starts making month-end payments of $2,300 when she begins working, how many payments will she have to make? So the month-end payments tell us this is an ordinary annuity, not annuity due. But with monthly payments and compounding annually, this is a general annuity. And she borrows the money now, but doesn't make payments for 3 years. So it's definitely a deferred annuity. So again, the diagram looks incredibly similar to the other ones. But we want to figure out the logic of how we have to solve it. So she borrows a chunk of money over here. Interest is owed on the money for 3 years here. Then she pays the loan off with monthly payments, which is here, but we don't know for how long. So the logic is that we can start with the amount borrowed and see how much money she owes before she starts paying it off. And then we can do the second part where the payments, which is the annuity, and figure out how long that's going to take. So if we did this with Excel, we start with finding the future value formula in the first calculation, and then we're going to use NPR to find the number of payments. This is complicated because this is a general annuity. And if it's a general annuity, when we do the annuity portion, we're going to have to know the value of P. So we have to find I. We have to find C, which is always compounding over payments. And then we can find P. And we're going to store this in register 3. So make sure if it's a general annuity, you can do this ICP process and come up with P. And you're always going to want to store it. So although this is a general annuity question, the general annuity concept is only a problem when we have to deal with payments. It's easier to calculate the future value without using P. So for the first time period, there's no payments. So we could use P and it would make it a little more complicated, but it's easier to ignore the P and just calculate the future value of a sum of money. So we have to calculate I. We have to figure out that it's 3 years at one time a year is just going to be 3. There's no payments. We made this 6,200 positive because this is money she gets, even though she spent it on a car. In relation to whoever she's borrowing the money off, she got this money. And we found out that although she borrowed $6,200, after 3 years, she owes $7,732.37. So now we can start the annuity concept. Here we have to use the value of P for the rate. Her payments are negative. The present value is that amount of money we just calculated, but we've now made it a positive amount because in relation to this time period, it's a positive number. The future value is 0, of course, because she doesn't owe any money once the loan is paid off. And it's an ordinary annuity. So this is a 0, not a 1. So we get this weird answer, 37.78. as she's making monthly payments, we need to round up to the next whole month. So she needs to make payments for 38 months. We could translate that into years and months. We divide that by 12 to get years. We can see the 3 years, subtract the 3, and then multiply what's left by 12. We get 2 months. So she's going to make payments for 3 years and 2 months. And that last payment will only be a partial payment. But they're really only asking us how many payments she had to make. The answer was the 38. We can do this on the BA2 plus. First off, make sure BGN is not up. Now we've got to set payments on monthly. Well, for this first time period, we're not worried about setting the compounding separately because it's not an annuity in this time period. She borrows the money for 3 years, once a year. This is the interest rate. The present value is the amount she borrowed. We're making no payments and we ignore the future value, but we calculate the future value and we get the same answer we did before, and it comes out negative again. But we have to make it positive for the next time period. And in this time period, we have to set the payments, which are monthly, separately from the compounding, which is annual. So, and I can see that I've slightly screwed this up. Let me try and fix this. These should not say clear here. What these should say, and I'll see if I can find what I have to put in there. Symbol, down arrow, close. So this one should just say down arrow. You might want to change that on any notes you have. As I can see that I've made several mistakes in typing this up, I will probably send you these again with the corrections I've made.
Hi, Mr. Brown. On the first calculation, why is the payment per compounding year or P/Y is 1 when it should be monthly?
Well, because there's, although it stupidly says payments are monthly, in this case, there's no payments. So we could ignore that. Let's see if we can actually get rid of that. We can just set this to once a year because the there's no payments during this period. Thank you for pointing that out. I shouldn't have left that up there. For this time period, payments per year are just 1, even though there's no payments.
Okay, thank you.
Just like we did up here, we just did 3 years. We didn't worry about the fact that we know the payments are going to be monthly, but there's no payments here. So we're not worried about them. But thank you. I shouldn't have left that up there. So down here, we do have to worry about the fact that payments are monthly and compounding is annual because this is the annuity period. So we set PY equals 12 and then enter that, hit the down arrow, and we can separately set CY equals 1 and then hit clear a couple times. We don't know N. That's what we're looking for. The interest is just 7.64. Here we're using the future value from the first calculation becomes the present value for this time period. But she makes payments, so these are negative. I have no idea why this says plus minus. It should just say future value. And we compute N, and we get 37.78 again, which we round up to 38, which we're translating or interpreting as 38 payments, because they haven't really asked us about years, months, and days. So we could do this by hand. The first calculation is not an annuity, so it's just a compound interest calculation. And we'll find we get exactly the same answer as we did by the previous two methods. The second calculation is an annuity calculation. It's a fairly complicated one. But if we plug all these pieces of information in correctly, we'll see we get exactly the same answer. So, do you think that calculation works, or would you like to see it done on the calculator? If you try it yourself later and and it's not working, definitely send me an email and we'll try and figure out what's not working for you. But give it a try. Remember, for this calculation, we have to have P, not I. Up here, when we're just doing a compound interest calculation, we can use I. We don't have to worry about P. But down here, as it's a general annuity, P always shows up if it's a general annuity. Okay. Trusting that that made some sense. Let's see what else they can do to us. So can you see the Excel screen? I didn't lose you again somehow.
Yes,
So-
sir.
We're good? So Samantha wants to be able to withdraw 500 at the end of each month for 2 years while she travels. Nice. Starting 3 years from now. If she invests 10,000 now to earn 4.68% compounded monthly until she begins to travel, what monthly compounded nominal rate of interest must she earn after she starts to travel? So they've told us it's at the end of each month, so it's an ordinary annuity. The payments are at the end of each month, and it's compounding monthly, so it's a simple annuity, but it's starting 3 years from now, so it's a deferred annuity. So as this is a simple annuity, we don't need to calculate P, but as it is a deferred annuity, we do need to do 2 calculations. And here's basically exactly the same picture. We can see here she puts 10,000 in, we know that. She lets it earn interest for 3 years. And we know the interest rate for these for 3 years. And then she'll have a sum of money up here. And then she's going to take payments out for 2 years. We know, what do we know? Oh, we know how much she wants to get, $500 per month. And we know how long, for 2 years. What we don't know is the rate of interest she has to be getting in order to make this all work. So let's take a look at what we can do. We can calculate the future value. So here's her 10,000 going in, it's negative. Here's the rate of interest, 4.68% divided by 12. We have to calculate that and put it in there. It's 3 years, 12 times a year is 36. We have to calculate that and put it in. There are no payments, and it's an ordinary annuity. And so we find that her 10,000 after the 3 years is worth $11,504. So that's what she's working with. So during the second time period, we're taking payments out. So we use Excel's rate formula. We can see the number of periods is 24 because it's 2 years, 12 times a year. The payment she's getting is 500. And so this is a positive number because she's getting it. The 11,000 is negative. That had to go into the investment. The future value is 0. There's no money left at the end. It's an ordinary annuity, so this is 0. And they have something called a guess here, but we can basically ignore it. I've never seen a situation where we had to use it. So we get this number, but what does it mean to us? This calculation gives us a value for I, but we need to understand it. As we were dealing with monthly payment, this number is the monthly interest rate. So multiply by 12 to get an annual rate, and multiply it by 100 to turn it into a percentage. And for some reason, I decided to round it to 4 decimals. It turned out to be 4.0842%. So when we're dealing with Excel, we had to interpret what that number meant once Excel spits it out. It's actually easier on the BA2 Plus. Again, it's not an annuity due, so make sure BGN is not up. Payments are 12, so payments are monthly, even though there are no payments during this calculation. And the calculator automatically sets compounding to 12. We still have to figure out the 36, 3 years at 12 times a year. But we don't have to translate the 4.68. It's not 4.68% and not 4.68% divided by 12. The BA2 Plus just lets us put the interest rate straight in there. The 10,000, which is negative, because we had to put it into the investment. During the first 3 years, there are no payments, but we have to tell the calculator that. And we're looking for the future value. And we compute future value. And hopefully we get the same answer that Excel gave us. So now we look at the 2 years of travel, and we're going to calculate the interest. Again, we set PY to 12, enter C/E, C/E, which is clear, and the calculator knows to set compounding per year to 12. 2 times a year, 12 times a year is 25. We have to figure that out for the calculator. We can ignore the interest per year, which is what we should be computing. And this is the amount we got out of the first calculation. We have to make it negative because it's money going into the investment. The payment, which is coming out, is positive. And again, there's no money left once she's finished traveling. So we compute IY. And the nice part about doing this on the BA2 Plus is we don't have to do anything to interpret the answer. It just gives us the answer we want, which is nicer than Excel. Now, amazingly enough, we can only do part of this by hand. We could do the first part by hand, where we're just calculating the future value of her $10,000 for 36 months at 4.68% per month. And you'll find out you get this future value. But amazingly enough, in your textbook, they don't give us a formula for calculating the rate of interest. They assume we're either going to do it on the BA2 Plus or on Excel. The process of doing it by hand is apparently tremendously complicated and time consuming, and they don't want you doing it that way. So any thoughts or concerns at that point? Once you understand the concept of a deferred annuity, these questions should be fairly straightforward because you're not learning any new formulas here, but you have to do these 2 calculations every time. Let's look at the last one. Let's enlarge this. So you can all see the question we're dealing with. Santini Construction is evaluating a project to build a bridge over the Salmon River. The project is currently worth $14 million. In 1 year, when the construction is 30% complete, there will be a one-time payment of $3 million. Over the next 2 years, quarterly payments of $1.62 million will be made. And I've put in brackets here at the end of each quarter. I don't know how they expected you to know that it was at the end and not the beginning, but it's at the end. The job is scheduled to be completed within the 3 years. During the first year, money is worth 7.25% compounded annually. What is the annually compounded interest rate for the annuity period? So very much the same concept as the question we just did. So payments are quarterly, but interest is compounded annually. So we know this is a general annuity. There's a 1-year deferment. So this is a deferred annuity. And we know this is an ordinary annuity because the payments are made at the end of the period. So the diagram looks a little different here because they start with the full value of the project and they're not making any payments. Whoever is getting this bridge to be built is not making any payments on the full value for the first year. After the first year, they make this one-time payment of $3 million. And that's why this jots down here a little. And then they make payments of 1.62 million for the next 2 years. So the diagram here, the logic works. We've got to figure out how much is owed on the project after a year. Then we do a calculation involving the 3 million, and then we can figure out the rest of the time period and figure out what interest rate will be they're hoping to get over this time period. So because it's a general annuity, we know we're going to need the value of P somewhere. So we have I, we have C, and we get P. And I'll store that in register 3 because we'll need it. So for the first period, there's no payments. So we don't need to worry about using P. During this time period, there's just the present value of the 14 million at the interest rate of 7.25% for 1 year. They make no payments, and they find out that at the end of the year, they owe 15 million and another 15,000. So at this point, there's a $3 million payment made. So we subtract 3 million from 15 million, get 12 million. And don't know why this hasn't fit in the space. Let's help it a little. So then we can use the rate formula. So the rate equals N per payment, present value, future value, type, and guess. And so this is 2 years quarterly, so it's 8 payments. We're making a payment of 162,000, and we're paying off 12 million. And in the end, there's no money left. And we can basically ignore the guess. So Excel gives us an answer. But the problem is, the answer Excel gives us is annoying. Because this is a general annuity that works with P, this answer is P. Excel expects us to use the equation for P, but solve for I, which for some reason they don't give you this formula in the textbook. I'm not sure how they expected you to do it. So if we start with the formula for P and solve it, we end up with a formula for I in terms of P. And we can actually plug in our information into this and come up with an answer. So we come up with this answer for I. We multiply it by 100 and we round it to 4 decimals. And so we end up, after a lot of work, finding out what I would have to be. So when we do this on the BA2 Plus, the BA2 Plus is much more user-friendly. We don't want BGN. For the first time period, the payments is 1. The calculator will automatically set CY to 1. It's only 1 year, 1 time, so N is 1. Notice for the interest rate, we're just using I, not not P, because during this time period, there's no payments. So we're not worried about it being a general annuity. The 14 million, well, we made it negative. There's no payments, and we calculated the future value, and we got exactly the same 15 million and 15,000. We still have to make that one-time payment of 3 million. So this becomes 12 million and 15,000 that we owe. Now, for the second time period, we have to set PY and CY separately because it's a general annuity. So PY equals 4, PY equals 1. It's for 2 years, 4 times a year, so N is 8. We don't know the IY, that's what we're solving for. So I should fix that down here, compute IY. The present value is the 12 million. I've made it negative. And we're told the payment is 1.62 million. And the future value is 0. And so if when we compute IY, notice this time, this gives us our 7.0337. The same number we got after a ton of work here. The BA2 plus just coughs up the answer we want right away, which is so much nicer than what we had to do on Excel. So I can bet you're definitely going to do this on the BA2 plus and not find interest rates dealing with general annuity on Excel. We could only calculate part of this by hand. The part of this that is just a compound interest, not an annuity, you could have done this by hand. It's fairly straightforward. You're just calculating the future value of 14 million at an interest rate of 7.25% per year for 1 year. And you'd come up with exactly the same answer. But similar to the last question we did, you're not going to use a hand formula to find the interest rate. They don't even give us one. So hopefully those will make sense when you go through them again on your own. I had to fix several typographical errors that I wasn't diligent enough to fix before. So I will send you these Excel files again to make sure you have all the corrections that I did. And unless there are any questions, I will wish you good luck on your test. I've been asked,
Excuse me, sir.
is there a financial calculator handout for this compound interest chapter? I don't actually have one because you've seen all the calculations before. I could try and create one. Yes. So Shady, if I do manage to create one, I'll send it to you, but you can probably just refer to the financial calculator calculations I've done in these Excel files.
Hello, Mr. Brown.
Yes.
Can you please available a chapter 3 part A homework assignment on Moodle because it is disappear right now.
Oh, have you checked it recently? Because
Ye-
I checked it, chapter 3, part A, because let's see. Let me take a look at it now. Chapter 3, homework assignment, compound interest, part A. Yeah, that one has disappeared because that assignment was on your first midterm test. But chapter 3, part A for week 3, that one should be available. It's showing to me it's available now.
Yes, but because chapter 3 is now in this midterm and the part A is not available on Moodle. Only part 3 is available.
Oh, weird. Because when I look at it from my side, chapter 3, part A, homework assignment week 3, it says it's visible to you.
It is not visible on my Moodle. Maybe it's visible to other. They
Um,
can check.
Can you sign out and sign back in and see whether it becomes visible?
Okay. If it's not
because-
visible, then I mail you.
Sure. Well, I'll wait for you to sign out of it and sign back in. I only fixed it at the beginning of this class because someone asked me to fix it. It wasn't visible up to today.
Okay, I'll try.
Yeah, definitely send me a message if it doesn't become visible for you. Someone else has asked, will you have a 24-hour window on June 18th? Yes, you will. It'll open Vancouver time at 9 a.m. on the 18th, and it'll close at 9 a.m. on the 19th, Vancouver time. So you have, although it's a 3-hour test, you'll have a 24-hour window to decide when you write the test.
So what is the deadline of today assignment?
Could you ask that question again?
So deadline of today assignment.
Oh, today's assignment is this is assignment number 7. So you're doing a test on the week of July 6th. So the week of July 6th, the class is on the 6th. The actual test will be on July 9th. So although the schedule of dates says it's due, let's see, says it's due June 18th, but in actual fact, I'll leave it open till July 9th, I think that is. Did I say? Yeah. So I was just wondering, as the last financial handout on Moodle is amortization chapter. Yes, the last actual handout, I have the formula sheets for all the chapters except chapter 16 at the moment. And so when those actual handouts, those were only went to amortization. I don't have any handouts like that for the other chapters. All I have is the formula sheets for chapters, basically 13, 14, 15, and 16. Although amortization, I think, is chapter 14. So it's only chapters 15 and 16 that I don't have handouts for.
Okay, that's fine, Mr. Brown. Thank you. Just clarify for the compound interest on midterm. So it includes ordinary general annuity, simple annuity due, and general annuity due, right?
Let me make sure of that. Let's check. It's let me. Trying to see where I have that specified. So it should be what was assignment number 4? Compound interest assignment 4. Let's find that. Let's look at it from that point of view. So compound interest assignment 4 is ordinary general annuity. Compound interest 5 is simple annuity due. And compound interest 6 is general annuity due. So, is that what you said?
Yeah, I just wanted to confirm. Okay, thank you.
Okay, yeah, those are the 3 sections that will be on there. So any other questions people need to ask today?
Hello, sir.
Hello?
Yeah, chapter number 3, part A is now visible on my Moodle.
Oh,
Thank
good.
you.
Okay.
And I also have a question. In week 4, in chapter number 4, I attempted the 10 questions and my 10 questions are correct, but the answer shown on Moodle is wrong. I also sent the question to you. You also told me that your answer is correct, but there is there is a problem in Moodle. So I have to reattempt the homework assignment, or you consider my 10 grade?
Let me find that. So it's chapter 4. Is it
Yes.
the, so it's, let's find that. Homework assignment, chapter 4, right?
Yeah,
And who is it I'm talking to?
Manmeet.
Manmeet, okay. Okay. And we want to look at your second attempt. And question
Yes.
number 10. Oh. Oh, I see what happened. I fixed that problem in Moodle, but I have to regrade it. Give me 2 seconds to regrade it.
Okay. Thank you.
I had that problem too, but I reattempted it multiple times.
Ah, okay. Yeah. Don't hesitate to send me an email if Moodle is doing something ridiculous. So Manmeet, that should have fixed it by now. It's fixed it on my end. Yeah, if you get me to change a question, if it doesn't change on your end, then that's probably because I've forgot to tell Moodle to regrade it. And if you ask me to, I'll remember to do that. Someone has asked compound interest chapter today. What we did today will not be on this midterm. What we did today will be on the third midterm. Sukhbir, the 3 sections that we'll do today, or that will be on this midterm, are ordinary general annuity, simple annuity due, and general annuity due.
Thank you, Mr. Brown. It's visible on my model.
Okay, that's good. Yeah, that was my fault. Although we fixed the numbers, I didn't remember to tell Moodle to change the grade. So, any other questions before I wish you good luck on Friday? I'm recording this session, so sometime later this afternoon or evening, it should be available on my YouTube site. Are you able to access, were you able to access last week's class on YouTube?
Yeah, yes, sir.
Oh, good. Okay, that helps. Okay, in that case, we'll sign off, and I wish you all good luck on Friday.
Thank you, sir.
Take care.
Thank you.
Thank you.
Bye now.
Thank you, sir, and bye.
Thank you, sir, and bye. Have a good day.
Yeah. Don't hesitate to send me messages during the week if you have questions.